Hi, my name is Leila Jeanpierre, and I am a neuroscience major at Florida Atlantic University. My partner's name is Vanessa Gregoire, and she is a computer science major at Florida Atlantic University. While I focus mostly on research, she has been helping me and is focusing more on the electrical engineering and computer science aspects of this project. The title of our project is Solving Part of the Problem of the Lack of Accessibility on a college campus with a hands-free device. The problem we are attempting to solve is that we want to make wheelchair accessible doors with push pads more accessible to the students in wheelchairs and the faculty on this campus that require their functionality. I came up with the idea for this device and research from an observation I had in my own school's cafeteria. I saw a student in a wheelchair struggling to get through the wheelchair access door with the push pad. After helping her get through the door, I thought about how someone would not always be around to help students or faculty like her, and I believed making this interaction with the door hands-free would be a progressive solution to a massive issue of accessibility for people in wheelchairs on college campuses. This is important to me because students, faculty, and frankly people in general who are in wheelchairs deserve the same manageable accessibility as those of us who are not. The device my partner and I created includes a microcontroller with a breadboard, ultrasound sensor, wires, resistors, LED lights, and an accelerometer sensor. This is also paired with the receiver that collects the signals given from a password that the user will create with the device using motion, and that will allow it to be able to unlock the code that will open the targeted object. As a part of the research for this device, I analyzed wheelchair accessible doors in 20 buildings, which was about 53 doors across Florida Atlantic University's campus to see if they fit within the ADA's suggested regulations. Those regulations include the wheelchair accessible door being at least 32 inches in width, the push pad for the door being within a 1 to 5 foot radius from the door, from the outside and the inside. There is an exception for push pads located on the ledge of the door's frame. The height of the push pad must be within 34 to 48 inches tall. If the push pad is not functioning properly and you are required to open the door manually, the door should not require more than 5 pounds of force to pull or push open. Pushing it open should not strain the arm, wrist, or hand. And lastly, the push pad must be functioning from the inside and outside. The table below shows the results in average from my analysis of the doors, which includes all the regulations mentioned above. I went up to each of these doors and measured them with measuring tape for all the aspects mentioned in the table to see if they fit within these regulations. The results from my research found that 77% of the 53 wheelchair accessible doors I analyzed in the 20 buildings I went to on campus were not within full ADA regulations, which means only 23% were. Most of the doors were not fully within ADA regulations because the push pads were too far from the door, but they successfully fit into many of the other requirements listed in the ADA suggested regulations for these kinds of doors with push pads. Another interesting thing that I discovered doing this research is that a great majority of these buildings did not have wheelchair accessible doors beyond the first floor, which made me question if people were aware that being in a wheelchair does not end on the first floor and that access to each floor is also something that we should work towards and something that is important. There is a similar invention surrounding this idea. It is called Portal, and it was created by engineering students at Brigham Young University. Portal is essentially an iPhone application paired with the motor attachment that opens wheelchair accessible doors when the user is within a 5 foot radius of the door. My device will be more accessible and provide a level of security that Portal does not. Since my device will, upon its completion, be attached to your wrist, people with or without iPhones will be able to use it. Also, having the user create a password using motion with the device to unlock the door ensures that the door will not be open just for anyone when a wheelchair user is close to one of these doors. Currently, my project is able to function on a miniature scale. It is able to do what we would want it to do on a wheelchair access door. With the help of the microcontroller and its components, it is able to use a passcode to unlock another code that will unlock another external device. In the future, I will shrink the microcontroller and its components to a point that it will be placed in a frame that is the shape of a wristwatch, and I will make sure the receiver that goes with this device will be implanted in the push pads of wheelchair accessible doors. Ultimately, I want to bring the device to wheelchair accessible doors across my campus and others. In order to do this, I will also pitch my idea to investors in the assistive technology field in hopes of securing a deal that will allow me and a team to create more prototypes of this device and explore more ways to expand this idea. Thank you for your time and consideration.